Welcome back. Here we see a world map with income distribution differences across the world. And you see that all countries are to some degree unequal. 25 is the lowest Gini index that we see. But the differences in inequality are very great. Some societies are much more unequal than others. Why? It turns out the answer has a lot to do with the environment. Here we see an agent-based model with a world with heterogeneous fertility. The lighter colored cells indicate richer soils where more grain can grow. The simulation starts with equal numbers of people in 3 income classes. Red means poor, green middle class, and blue means rich. And when we run the simulation, everybody goes to the lightest cell around them to harvest, making that cell temporarily empty of grain, which turns it dark, and then it will turn light again when the grain regrows. Soon, you can see the income distribution becomes very skewed, with many poor people and only a few rich people. How does that happen? Well, quite by chance. Of course, the rich people have better soil, but the fact that few people become rich and many become poor is a case of self-organization. Such a distribution is called a power law distribution, and you see them a lot in the real world. As for differences in income, in the real world, nations have taxes, or there are wars or diseases that redress imbalances. The point I want to make here is not about money, though. It is simpler. I just want to point out that one can easily create a heterogeneous environment in an agent-based model by giving properties with different values to the patches. Let's now take an example from the circular economy. This is about man-made waste. You may know from your own experience how waste can make parts of a landscape unusable. We shall investigate a simplified agent-based model about this. And here we have it. You see a world with red and blue people. The red ones are called the wastefuls and the blue ones the recyclers. If you ever find yourself picking up rubbish that others have left, well, you'll like this model. When there are only recyclers, they use the land but do not destroy it, because they only use part of the resource and recycle everything. So the land remains as new, shown in green. But here we also have wastefuls, and they actually leave waste and deplete the environment. They consume everything, they dump, they make the land unusable, making it turn yellow. It regenerates only slowly, depending on the slider. Regeneration, where is it? Well, the print is too small. You can use it yourself and you'll see the slider. If there are only wastefuls, they will develop a degenerated land, and you will see that their numbers decrease. See, the population decreases. They cannot sustain a large population. Now, let's mix the two types. Then you see that the recyclers restore the environment depleted by the wastefuls. The restored patches turn lime-colored, lighter green. Can you see the effect on the overall population? See, it can sustain itself better. To explain the population trend, think of the slider cost of recycling waste. Recycling waste cost, it's here in the middle. I have now made it more expensive to recycle. And as you can see, this is not good for the recyclers. Their numbers decline. After which, also the numbers of the wastefuls starts to decline. So here we see a tragedy of the commons unfold. And this goes to show how even a model that is obviously not realistic can be useful. The model, I think, can serve as an excellent conversation piece, sparking debate regarding which assumptions are or aren't reasonable about the sliders of that agent-based model, and what the consequences are of those assumptions. For instance, in your society, who pays the recycling waste cost? Is this changing? It's going to be really important for the circular economy. Okay, summing up, you have seen 2 models in this video about the role of the environment. In the simple income distribution case, the environment drives the wealth of the agents. In the more rich recycling model, the agents first change the environment, which then in turn affects the agents. And there are different kinds of agents, and the composition of the population has a big effect on the result of the simulation run.